Good morning or afternoon, wherever you happen to be. My name is Mr. Sandin, and I'm going to try to show you how to work with a box and whisker plot today. A box and whisker plot. It's all about finding parts of the data, how much of the data is in a certain place. So oftentimes it's just drawn with either a line or a big dot, and there's your whisker, and then you've got your box, and the box doesn't have to have the line in the middle on one end or the other. It might be far down the other end or close to the middle, and then it comes back out and has the whisker. Now, these might be dots instead of lines there, but oftentimes you have a number line underneath it, and say this was 70, and this is 80. Here's 90, not very well spaced. Here's 100, 110. Well, maybe this spot is, let's say 95, and this spot is 107. So we've got several pieces here. The first piece is this matches up with 70. This is the lower extreme. This is lower or first quartile. This one, I'm going to have to bring it down below so I have a place to draw it. But this one here is the median. And we know what a median is. It's the middle point of the data. Right here is the third. And they refer to this as the third or upper quartile. And they refer to that as the third because the first quarter, the second quarter is the median, and the third quarter is the upper quartile of the data. And then this spot right here is the upper extreme. And there might be another word that some books will use for it, like the highest value or the lowest value. But many books use upper extreme and lower extreme. So it's the lowest point of the data, the highest point of the data. And then you have, what's interesting to me is, and most important about a box and whisker plot, is the distance from this spot to here is 25% of the data. From the 80 to, in this case, the 95, from the lower end of the box to the median is 25% of the data. From the median to the upper end of the box is also 25% of the data. And from the upper box to the upper extreme is also 25% of the data, which makes a lot of sense since we're talking about all of it, 1, 2, 3, 4, 25s is 100% of the data. So if I were to ask you what percent of the data is between 70 and 90, you would not actually be able to give a clear answer to that. You could say it's over 25%, but you're not exactly sure how much of the data is between here and here. You do know if I said how much of the data is between 70 and 95, you could say, oh, 225, so that's 50% of the data. If you asked what percent of the data is between 80 and 107, you would say that's 75% of the data. So if you're asked a question about, say, 70 to 90, you can say not enough information to answer, or you could say at least 25%. Those are the types of answers you could give. Now, here's another kind of answer or question that you might be asked, and that is between what two values of data is the bottom 25% of the data? And you would say between 70 and 80 is the bottom 25% of the data. If they asked you how many 70s are there, say these were grades, and they said how many people got exactly a 70, the only way you could answer that, other than not enough information, is at least one, because one of the lowest value is 70, and so you would have to only be able to say at least one. But that's the best answer you could give there. Now, in terms of, say somebody asks you, what percent of the data, not what percent, but between which two values is the top 75% of the data? Top 75% of data. Between which two values? You'd have to say 80 and 107. And that would give you the information. Now, we're not going to ask you, I don't believe, to create any box and whisker plots, but we may ask you to read them and try to understand what they're telling you. Now, one of the things to notice here is this is the amount of data in here is 25%, and that's 10 values, right? Between 70 and 80. This is further spread out between 80 and 95, so it's just spread out further. It's the same number of data values, but it's spread out further. This is very condensed. We don't have a value for this, but we could call that, say, 97 or 98, whatever it is. Usually it's going to be listed. Now, if you look at this, that's saying 25% of all this data is squeezed into 95, 96, or 97. That's a huge amount of the data in just those three little bits, where this is 10 values, or 11, and that's got 25% of the data. Only 3 values have 25% of the data. So it's very condensed. You might have something way spread out. So let me do another box and whisker for you so that you can see another example. And say your number line was here, and you have 10, 20, 30, 40, 50. Just so we have some numbers here. And say we have our lower extreme at 10, upper extreme at 50, just to have values. And then say the data is way up here. Now that is skewed one direction. And I don't know if we ask you anything about skewing. I don't think so. Good, good, good. But it's spread way out here. And most of the data is up here. Now, if I were to change these values to something like this, or no, let's call that 60, 70, 80, 90, and 100. If somebody gave a test and these were the test grades, would you say this was a good test or a bad test? Well, I would say the students did very well. So very few students got in the 60, 70 range, a few in the 80s. 25% is between 85 and 90. About 25% is between 90 and 95, and about 25% is between 95 and 100. So 75% of the data is at 85 or greater. I'd say it's a darn good test in terms of for student results. Maybe it was too easy because so many people went up here. So that's just one of the little ways you can think about information. If this were temperatures, average temperature, daily temperature during the summer, you might say, wow, that was really hot summer, because wherever you are, it stays somewhere between 85 and 95 for 50% of the time, 75% between 85 and 100 degrees, and very little time in the lower temperatures. So that might be an interesting piece of information to talk about. So that's the basics of Box and Whiskers. The focus is on 25%, 25%, 25%, 25%. The middle of the box is the middle 50%. And I hope you understand it. Have a wonderful day.